I'll introduce myself. I'm Joseph Sarafian, joined by my partner Ron. We're architects based in LA. We go back to, we met in grad school at UCLA back in uh, 2013. We've opened a practice together in 2017. We have combined over 50 years of experience over 25 jurisdictions in terms of getting approvals. Um, and both, our portfolio includes work that's both fire rebuilds in Malibu and the Palisades. Um, and we've been helping clients not only navigate the design process, but the fire rebuild process. And that's experience that we can, I think, transfer to any potential clients. And this is something that as architects, we would provide anyway. As architects, we're advocates for the homeowner from the beginning. We're not a design build firm. We don't do construction. We're an architecture firm in the traditional sense, and we'll talk about how that's valuable today and why it's important to hire an architect um, early in the process so that we can advocate for your needs and help you navigate the entitlement process, help you navigate getting multiple bids from contractors, um, rather than getting locked into a design build firm or a construction firm from the beginning, and kind of being forced to continue with them throughout the design. So we'll talk a little bit about our process today, um, and how we can be your advocate and not just your architect. So my background, I have kind of a reputation in the architecture world for doing complex digital modeling and design, fabrication tools, which has led us down a few interesting roads that we'll talk about today as far as automation and construction technologies, including light gauge steel, um, and other building systems that we've
We've
introduced to
introduced.
our clients. Um, my partner Ron, do you want to talk a little bit about your background?
Sure. So I've been in the architectural and construction industries for about 38 years now, and having had a background in construction and architecture, we really understand all the ins and outs of the
Like a
process,
big marketing campaign.
and so we also work really well with contractors because we understand their language, having been there in the past. We have done multiple single family projects, fire rebuilds in Malibu, working on some of the Palisades now, uh, and we have done a tremendous amount of research on these kinds of processes, and we're going to talk a little bit more about those um, going forward in just a minute. Let me see if I can advance this. There we go.
Yeah, so our work has been published internationally. We have design research that you see in that book that is now in the permanent exhibit at the Vienna Museum of Science and Technology. Um, and you might be thinking, how does that relate to architecture in LA and the Palisades? I think for us, this is part of an inquiry and kind of a level of design research that we put into our practice where we're constantly exploring building materials, systems that make sense for the client. And in this case, that includes, fire resiliency and using not only materials, but design strategies that make buildings more resilient, more sustainable. We recently completed a project that's fully net zero. It exceeds sustainability and building code standards. We'll talk about that. It's the last project that we'll talk about today. So, you know, how we add value, we'll talk about our process and, the what we bring to the table. We'll talk about how fire resiliency is just another design problem and how it's not necessarily a, a yes or a no question. It's just something to factor into our process. Um, Ron will talk about the how wildfires spread and what architects can do about it. We'll talk about the things that we can control in all of this. And then we'll mention two what we call partial prefab prototypes. So, we propose in a lot of these fire rebuilds a partially prefabricated solution. And we'll talk about our role in that. Again, we're not builders, we're architects, but we've discovered solutions that help clients get construction a lot faster and help them rebuild with non-combustible materials like steel. And so we'll mention some of those and how they can save money, even though the reputation for steel is that it's more expensive. So this is the one of the images that we show new clients when we first have an introductory meeting with them. And if you haven't reached out already, I'd recommend all of you contact us if you'd like to tell us about your project. That first meeting is completely pro bono. We want to get you as much information as we can in that first meeting and hear from you. So after this, if you'd like to reach out, we'll have our contact info at the bottom. So in that first meeting, we discuss all of the phases of design, and this is true for the majority of architects out there. What we offer in each of these phases is not only peace of mind that the design is progressing according to the timeline and the plan set out, but a peace of mind that we're going to help maintain your budget. So, in the beginning, we asked for a construction budget, not really in relation to our fees, but in relation to ensuring that the project is being designed according to that budget. And that's a level of detail that you don't always get from a draftsperson or hiring a contractor that says that they have an architect who works with them and is really just a draftsperson. Um, we have our own architecture licenses and California law to maintain. And so we ensure, we make sure that your projects are designed at each phase according to the level of development that's appropriate, starting from initial ideas and schematic design. And that design from left to right progresses in a kind of an evolution to gain more detail and more information as the project moves along. So big changes are easiest to make in the schematic design phase. We often start with a massing study where we'll look at how the building program, which is kind of your menu of rooms and spaces, we'll look at how that fits on the site and we'll send you diagrams and options for how the massing can be organized. How are we designating the public and private spaces of the home? Which sides of the site are we orienting the program on? How do we consider sunlight, natural light, the orientation? And those changes are, and those options are significant um, because they make a huge impact not just on the sustainability and performance aspects of the project. They have, a huge impact on site views and in some of the latest projects we're doing, we're avoiding neighbors not only in terms of views, but kind of setting the building back in the event of any potential fire to keep them set back in a safe way. So at the end of schematic design, we'll go through massing studies. We'll show you preliminary plans. I'll show you on the next slide what the schematic design phase looks like. But it's really the time, this is one of the floor plans that we would show in a schematic design phase. This is the time when it's the cheapest to make major decisions. So if you wanted to say, I wanted to put the living room and kitchen on the other side of the building, there's very little cost to making that change. It's, pretty painless. As the project moves forward in the design process and we've worked out, so in design development, we're developing all of the other systems. So the structural systems, the mechanical, electrical, plumbing, and we use BIM modeling. Which stands for Building Information Modeling. So the work that we do isn't just two-dimensional line work, we're modeling something three-dimensional. And so when it comes to solving structural systems and mechanical, we're actually modeling that three-dimensionally. So if there's a clash or some intersection, we can identify it in the digital design phase before it gets on site and it becomes a collision in the real world. So all of these things at every phase, the digital model is getting more and more advanced, and the design itself is able to take the next step. And with each phase here, we're getting approval from the client. We're ensuring that the budget is within the client's budget, and that we're designing to the quality standards that the client is looking for. And then during construction documents, we're putting together a set of documents. These are the blueprints, these are the drawings that are going to be submitted to the city and submitted for bid by various contractors. And so construction documents will include plans, sections, elevations, all of the views of the project that help the builder and help the building department understand the drawings. And I should also mention along the way, we're producing 3D views for you to understand the project. We realize owners don't always understand a set of drawings or what they're looking at. So we try to make it as easy as possible for you to understand what you're getting. So we'll create 3D views like the one that you see under design development. We'll show you interior perspectives that put you in the space and help you understand spatially what's going on. We'll also send you a digital file that you can open on your phone, and you can toggle the model, you can orbit and see, you can kind of probe it and look through every aspect of the project. So that's something we've been doing for clients for a number of years, and it helps them, again, have a sense of ownership and also understanding three-dimensionally what's going on. And around that phase, so once the construction documents is complete, we'll send out the drawings to multiple bidders. So we'll reach out to contractors. These are general contractors. If you have someone in mind, great. We have people that we've worked with in the past. We'd recommend them, but it's ultimately your decision to make who's actually being awarded the project and building it. So that's the kind of traditional design, bid, build methodology. There's a newer methodology that's design build that introduces either a contractor slash architect from the beginning. We've seen that with a lot of contractors in the Palisades and in LA, reaching out to clients and promising that they'll do everything from the beginning, but again, you're locking in a contractor before you've even seen the design. And there's a danger to that we try to avoid. If anything, when working with us, we're proposing an idea where we bring in a contractor as a consultant in the beginning because they do provide interesting insights on construction costs, labor availability, things like that. So what we typically recommend is we'll bring in a contractor early as a consultant. So you're paying them hourly. And then when it comes to time to bid the project, they're still going to bid the project among the other contractors that you recommend, but they'll maybe have an inside track or you've gotten to know them so you understand the way they work. So that's a way to not only get the information from the contractor early on with kind of a limited risk in the beginning, but also keep them honest and help them realize they're going to be bidding against other contractors when it goes out to bid. So in that way, it's kind of the best of both worlds where we're getting insight from them, but also maintaining competition among builders. And then this last phase, contract administration. So once the contract has been awarded to a contractor, we don't stop there. So our job continues on the job site. We'll visit the site periodically. And these visits vary depending on the general contractor and the project. But typically, we'll make periodic visits, maybe every 2 weeks or 3 weeks. And this is to ensure that your investment is being fulfilled, that the design is being, or the project is being built according to the construction documents. And again, there's building inspectors who will be on the site inspecting it for code compliance and other issues. We, as the architect, we're there to ensure that it's conforming to the design drawings. And it's really to preserve the integrity of the design. So, other architects may leave after the drawings are complete. We stick around through completion to ensure that you're getting the product that was designed and that it's built properly. And so again, that's another kind of check and balance that having an independent architect and contractor will ensure versus having them under the same roof, which you may not know if you're getting an honest opinion when it comes to billing or construction quality, things like that. We can call them out and help you have that assurance that you're getting what you paid for, and then they're not overbilling for a specific phase. You know, there's always scenarios like that. We've spoken to a number of clients who've said we've worked with contractors in the past that have, either walked the site or taken advantage of us, and it's not, it's not a good scenario. So as architects, we'll be your advocate through construction to help ensure that the design is being built according to the drawings. So, yeah, these are examples of schematic level floor plans. And again, we try to make these as beautifully illustrated as possible so that you can understand uh, the drawings and the spatial relationships between each room. But then we also create 3D views. So these views allow you to understand the massing of the project. And again, this is all at a schematic design level. So, this isn't much more developed than, maybe a month in. So we help you understand what you're getting and also advocate for you throughout the process.
So Joseph talked a lot about how we add value, but we also we're your advocates throughout the whole process. So we mentioned billing. That's one of the issues that we want to make sure that you get exactly what you're paying for, and you're not paying ahead of the construction during the process. So we like to talk about ourselves a little bit like the conductors in an orchestra, and the symphony that we're conducting is your project to make sure that you get what you envision, but also that um, uh, it's really about also easing the burden from you. We help to coordinate all of that work so that it becomes a more seamless and painless project for you. Um, so with that, we can coordinate all the consultants during the design phase, but also we help to coordinate the contractor during the construction phase and ensure that the project's going properly. Um, And so when we do a lot of research into building materials, and we built with multiple materials, concrete, wood, steel, composite materials, and we do this on a basis of understanding the project and the requirements of the site, and we advocate not one solution fits all, but we use the best possible solution for your project. Some projects are hillside, some projects are flat, uh, and they all have different sort of characteristics that we want to make sure that we're using the best possible design and material composition. So there's a few different materials that we use, um, like light gauge steel. We've used heavy steel, but all the projects that we're performing in the fire rebuild areas are non-combustible, and um, we as Joseph mentioned, we do projects that are net zero design, ensuring that you have the best potential energy conservation for your project to ensure that not that you just get a building right now, but it performs well over the long term and it saves you money. So we're sensitive to that and to the client's needs. Um, we always design with economy and quality. So we're adding value throughout the whole process. It's not like, hey, we say, here's a set of stairs. We're looking for the best design of the stairs and the most efficient way to put them in. That goes with every piece of the building. And we take a holistic approach to your whole design. So we have seen many pitfalls over the course of our careers as architects, and we know going in where you could have problems in terms of your particular construction process, and we help to ameliorate those things and navigate entitlements and permits. So Joseph mentioned we've worked in about 25 or more jurisdictions. We've worked with HOAs. We work with community plans. We work with the Coastal Commission. We 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 navigate all of that on your behalf, and there's it's you know some clients talk about the need to use somebody who's worked in your neighborhood before. Well, we've worked in many different neighborhoods, and we generally we generally get through the process faster than people that even know that neighborhood like they've worked in it before. And we're always looking for opportunities to make your home exceptional. It's not just going to be a replacement, it's going to be a massive improvement. So uh, here's another issue that we've been looking at a lot lately because we're finding that a lot of homeowners are having trouble making a construction budget with the insurance that they have been given, the payouts. And so we're working with people and finding ways to help to maximize your insurance payout. Um, so there's different ways that you can get insurance. One is the primary dwelling limit, and then you can get some additional money for extended cost coverage, code upgrade coverage, dwelling extension coverage, and tree, shrub, and landscape. So all of those things seem fairly obvious, but you have to know how to capitalize on each one of those amounts in order to get as much as possible from your insurance. But then there's also the personal property coverage that you have. And um, the thing that most people don't recognize is the personal property limit includes appliances and furniture. So, yes, you need to replace the furniture in your home, but maybe you're not replacing all of the furniture that you had. Perhaps some of those funds can go towards your construction cost. But moreover, appliances, microwaves, dishwashers, laundry machines, uh, uh, freestanding ranges and cooktops and all of those sorts of things can be used to help to help increase your the money that you have available for your construction. So we want to make sure that you've capitalized on all of those things so that you get the most possible. Sometimes that means itemizing your personal property, but we have ways to help make that as painless as possible. Then there's jewelry, personal property, and then loss of use. So we understand that everybody has different insurance. Some people have shorter, some have longer loss of use coverage, and they're all different amounts. Um, but that doesn't typically go towards the cost of your rebuild. So wildfire spreading. We've done a lot of research of this, and so there's three different primary ways that a home can be affected by wildfires: the flying embers and brands, radiated heat from adjacent uh, burning buildings next to you, typically, and direct contact by the flames. And so when we design a building, we design to really minimize the risk by all three of these. And so with heats up to 2,000 degrees, we have to make sure that we're giving you non-combustible materials as much as possible and direct contact embers, radiated heat aren't going to be as much of an issue. And so we've done a lot of research into looking at homes that were damaged by the wildfires but didn't burn. And one of the reasons we did this is because we were able to visually take a look and see what the issues were, how those buildings caught on fire. Buildings that were completely burned, there's no evidence for us to be able to determine exactly what happened. But here in some of these images, you can see windows and windows and doors are a vulnerable area. Unprotected eaves are vulnerable. Shrubs next to the house, crawl space and attic vents, wood siding, and wood pergolas and decks. All of those things help to bring the fire into the home and ultimately destroy it. In these cases, for whatever reason, those fires were extinguished and they did not continue to burn. Some of these homes had fire sprinklers that were still functional. Some of them were extinguished by the fire department. We don't know exactly what put the fires out, but it would have continued to burn had they done so, if they weren't extinguished. So these are all these vulnerabilities. When we design homes, we design to harden those particular areas and more. And so when we're dealing with windows and doors, we're dealing with tempered glass. That it helps. We also design with tempered and laminated glass, one layer tempered and the other layer tempered and laminated. That not only helps for fire resiliency because the laminated portion of it won't fail completely under high heat. It will help. There's a polymer film inside of it, so it will fail slowly. Same thing with doors, enclosed eaves or not having eaves at all, ensuring we have a defensible zone. I think we all know about all these issues and baffled vents. We prefer to actually build projects with no vents if we can, to eliminate that issue. It's also generally more efficient, less expensive to do things like slab on grade versus crawl space and attic spaces. Metal siding, and also when we design projects that we want to have some warmth rather than just metal all the time, or stucco, we can use metal plank siding that that is imprinted with a wood grain, and not only is it fire resilient, but it actually has zero maintenance. If you have wood on your building, you know that you have to refinish it over time. These never fade. They there's no water or element damage to these, and they're naturally fire resilient. We can also use these for pergolas and the like. Um, the other thing is when if fire comes through a neighborhood and the home doesn't burn, we all know that there's tremendous smoke damage, and so one of the things about building with net zero energy, we have very tight building envelopes. So we have air wraps and siding that interlocks for air barriers. We can even use a high fire resilient stucco if necessary, and we generally propose metal roofing and often metal siding as that wraps with the roof. Stone veneers or masonry, concrete masonry units, which can be burnished to look like stone, fiber cement sidings, and if we need to use wood, we use fire resistant treated wood. Joseph?
Yeah. So we're going to talk about two different types of partial prefab systems that we've used on projects, not only to save money, but to save time on the job site, which and then saves the contractor money. So we'll talk about metal buildings and panels. Ron's going to talk about the cleft house. The other one is computational steel stud framing. So it's a mouthful, but this second one is a system of light gauge steel that is printed to the exact size of each stud, and each stud composes the wall and truss. So everything is printed kind of like an erector set or a Lego set and gets assembled in a factory and flat packed. So walls and trusses are then shipped to the site and then installed directly on site. So while the foundation is being built, you can be printing the steel in a factory, shipping it to the site, and installing it in a matter of days versus weeks or potentially months of wood framing. So we'll talk about both of those systems here.
So the first one is metal buildings and panels. So um, this one is it's um, completely non-combustible framing, factory kit of parts. It's recycled and recyclable steel, high insulation value, earthquake resistant, no termites, fast on-site construction, and typically about two-thirds the cost of conventional construction. So the project that we're going to talk about first is the Cleft House, and this is a project that was in Venice next to the canals, and it uses a metal building frame, kind of a Butler building or some other similar things. And this was a duplex in Venice on a very tight lot and a very tight time schedule. It had radiant floor heat, super insulation. The walls were R30 and the roof is R30, natural ventilated and cooled. It's 2 stories plus mezzanine and roof decks. And this particular building had internal balconies because there was no room for external balconies on the site. So the structure is what we call hybridized. It's a combination of prefabricated components, and in this case, the steel frame was composed of a standard box frame that you would see in barns and factories, and an actual pitched barn frame. And so combined together, that was the particular composition of this building with customized extrusions and cantilevers that help to define the final composition. And so you can see here some of the cantilevered sections, and all of this frame was assembled in about 1 week on site. It took this particular project required a crane. There's other systems that don't require cranes, but this one was a more heavier gauge steel. And this is a timeline of that particular process. This building completed was about 6 months overall. And some of the things here, the particular contractor didn't use non-combustible internal framing, but that was their choice, what they were familiar with. And here are the panels going on and the overall shape forming, and then the doors being assembled on the
And
exterior.
what drove this system to be selected was that traditional custom steel that you'll see in high-end residential homes can often be cost prohibitive. So in this case, designing this house with custom steel would have been over budget. But in finding a company that could take a box and a barn and combine them, also modifying the design a little bit, we were able to save, a lot of money on the construction cost, two-thirds of the construction cost. So by kind of these creative problem solving solutions, we're able to save money. So it's not just about realizing the design that we have in mind, but finding creative paths to get there.
And this is the final product, which is, and you can see there with when the external doors open up, there's an internal guardrail, and the living room becomes a balcony. These buildings combined were about 4,200 square feet, and one of the issues with this is just the way we think about design. We try to maximize um, sort of the concepts that we come up with, so that one move in a building, we tend to have we want to have at least two rationalizations. So in this case, the duplex is typically a dark demising wall where the two units meet, and all you try to do is insulate for sound in that, but there's no light or air coming through that. In this case, we opened up the building, created a 5 foot gap where light and air could come into both units. And it became a 30-foot tall translucent wall that enhanced the building versus made it sort of a conventional dark framing. And on the right, you see an image of what that internal balcony looks like when the doors are opened up. The living room becomes a balcony, and there's the canal in the background. So, maximizing the views, which is what we do for every project. We don't just plunk a standardized design down onto a lot. It's customized to meet your particular site and your particular needs. Here's some of the images, interior of this building, light and airy. Um, and there's another external view. So this is just one of the techniques that we employ in the work that we do.
So this next one, computational steel stud framing. This is a technology that we were introduced to maybe 8 years ago. This is a system that's gaining popularity worldwide, but it's been slow to adopt in the US because of the strength of the wood framing industry here and the wood framing knowledge that a lot of contractors have. But we think it's not only applicable here before the fires, but especially after them. And I should also mention if anyone has questions, please put them in the chat, or if you want to save them for later, we'll have a Q&A and you can ask them. So we're happy to field questions at the end of this. So the beauty of this is that it uses non-combustible framing. So it even though steel is inside the building, it's not fire hardening the exterior like some of the other materials Ron talked about. It's internal, but it's just less fuel to spread in the event of a fire. It's recycled and recyclable. Steel is the most readily recycled material. There's less than 1% construction waste on site because the every piece has been cut to size by the machine. Holes have been stamped in it by the machine. Every stud has been labeled. So it's really just assembling everything in a factory, shipping it to the site, versus wood framing where there will be offcuts and end cuts to the framing that pile up. And with wood framing, you're lucky if you're seeing 10% construction waste. With this, it's closer to 1 or 0, because everything's been framed in the factory. It's earthquake resistant, no termites with steel stud framing. There's kind of a low skill site assembly because it's really just moving the walls, installing them in place. So that accelerates the construction timeline. And these steel buildings are built to a higher tolerance than wood frame. With wood framing, there's walls that are bowing and there's reframing that has to go in to fix any tolerance issues and plumb issues. With wood framing. Wood warps with moisture. So with steel, we don't have that problem. And we'll design these K braces into the corners of the walls to keep everything a triangle is one of the strongest geometries. So that keeps the corners true when we're installing. Let's go to the next one. So we've now built 9 homes in Armenia using this system. It was so easy that the first design that was selected was continued to be reprinted. This is a humanitarian project where traditional housing over there is built with concrete block that's unreinforced, dangerous in an earthquake zone. So we've designed and delivered these earthquake resilient homes built to Western building standards. And we've built a number of these. You can see the corrugated metal as a design feature and solar panels, solar hot water heating so that they're completely off grid. And so for these projects, we used volunteer labor. The construction cost was $40,000 US, but that's more about the cost of labor and materials in a foreign country. Um, Solar hot water heating. And we were able to frame everything you see in the bottom right in about 2 days. So 3 days total of steel framing. And this is with a language barrier with workers that didn't have a lot of construction experience. But it's a kit of parts and it only comes together one way. So it's a much easier learning curve than introducing another, foreign material. And so this is how it works. It comes off of a machine. Every stud is pre-labeled, pre-stamped, punched all of the holes. You can see the digital file there. And it's pre-engineered as well. So the software will tell you if this wall passes or fails structurally. So this would be the work that would be done in a factory. We now have two companies that we've worked with to deliver, one LA based, one abroad, and both deliver steel the way you see it here. Same machine. And these just get bolted to the foundation, and so you can see the diagram of the truss in the middle, that pink illustrated drawing. And so that's similar to what a builder would see. They would see every stud, how it's labeled, and then they'll install the truss that way. And so you can see with this, there's no guesswork. The contractor isn't guessing where each framing member is going to go. It's designed to fit in one specific way. And so this kind of takes the burden of complexity off of the plate of the contractor and into the hands of the architect. So contractors would typically have to determine where every stud goes in wood framing scenarios. With this, there's no guesswork, there's no improvising on site. There's a hole for every one of those webs, and it only fits together one way. So it's more about assembly than it is construction in the traditional sense. This was the net zero project I mentioned. This won 9 awards for sustainability. And the idea here was that the roof is like this protective shell. We designed a butterfly roof for this project. This was an ADU, so it's pretty small, 750 square feet. This is now in Placentia, but the roof itself covers down kind of the southern exposure, and we designed this lattice pattern that protects the southern exposure from sunlight and reduces heat gain, so it saves money over time. And it creates a kind of an interesting visual effect as well. The design features, it's two bed, two bath, again, on a really small footprint. Um, but the idea was that this was donated to Homeless Intervention Services Orange County, where it helps transition young youth from juvie and from the foster care system to get them transitional housing before permanent housing. So they would live here for a year and then get job training and education before they move on. So this project, again, zero net energy, 13,000 kilowatt hours, solar panels. We have a heat recovery ventilator. So it's a way of kind of not wasting energy. So if it's warm inside, cold outside, we still need to bring in fresh air from the outside. So we're not just bringing it in, we're running it past the warm air that's stale on its way out. So we're using the heat from inside to kind of preheat the cool, fresh air from the outside. So it's a way of saving energy, saving costs. We used a heat pump hot water tank, which uses the heat from the ambient air around it to heat the water. And then when it's not warm enough to use the heat around it, it goes into electric mode and it becomes an electric hot water heater. We use a number of smart home devices. Panasonic donated all of the sensors and air quality monitors. We have a roof that's R53. This is the insulation value. So the roof that's really well insulated, walls that are really well insulated, and all of that results in a home that I've walked into this in the hottest day in the summer and it was cold inside and nothing is running, everything was off. So the these performance issues, little devices, little insulation values, they may be more of an upfront cost, but they save all of that and more in the lifespan of the building. So this won 9 awards and was completed this past summer. This is some of the images of the framing. You can see the machine printing steel, um, trusses. We did have a glulam beam or a paralam beam here that's technically a wood product, but that was just to create the span that we wanted over the living room. This could have been built out of a steel truss. We just thought that we would expose it, but then ended up covering it. So another image of the construction. We used an Ox-IS product. This is instead of having plywood sheathing and rigid foam insulation outside of that, this is an all-in-one product that is three in one. It's sheathing, insulation, and the water resistive barrier, the WRB. So it's a three-in-one product. These are some of the images of the exterior. At first, we were exposing some of the steel trusses. This ended up getting covered in the end, but we used a standing seam metal for the siding. The interior, you can see, even though it's a small space, we vaulted the ceiling. We have clear story windows, making the space a lot brighter than you would normally see. And IKEA donated all of the cabinets for this project. This is a recycled cabinet product that they use. And so, again, part of what we do is creative problem solving. So, on this project, there was an extremely tight budget. So, we had to work with the parameters we were given and find a way to meet the kind of design excellence standards that we have. So, yeah, this is just another image of the Cleft House. And feel free to reach out to us. We'd love to set up an interview with you and hear more about your individual needs. Every project is different. There really isn't a one size fits all approach as much as we've talked about steel framing. Sometimes wood framing makes sense for the client and for the owner or some other building system. So we're structurally agnostic. We, design with whatever makes the most sense. But with each project, we're applying our kind of level of critical thinking and design expertise to each of these projects. So these systems, they're multifaceted decisions, and it's case by case. And yeah, we'd love to meet each of you and talk about a project that makes sense for your budget, timeline, schedule. So you can follow us on social media at Form Found Design, and then these are our websites and phone and email. So I think with that, we can open it up to questions. I don't think anyone's put anything in the chat yet. Does anyone have any questions? And this really is open-ended.
So what we're finding also is a lot of, a fair percentage of people in the Palisades areas and Altadena are still struggling with the decision about how to move forward. And so we we actually are able to help with that, and having an initial meeting with us can help you to make some decisions that will help you to determine what your next steps are if you haven't already um, taken action to rebuild. So as Joseph was mentioning, you can email us, call us, and we can help sort of guide you through that process a little bit.
Um, what what makes you decide a slab foundation versus a raised foundation? What kind of biases you one way or the other? What factors?
So slab foundations tend to be more economical. This is one aspect of it. There's they because crawl spaces are inherently combustible. Typically it's a way for embers to get inside a building. And with wood frame construction, that's particularly bad. We have the use we can now use baffled vents and other means to keep embers out of the building. But if it's possible to build with a slab foundation, we would prefer that because we find that it's more efficient. Um, it's it's less prone to maintenance issues down the road. Termites, insects, vermin. Finding a hole, working its way into the building. Um, and depending on the project, we can even heat that slab. and use, some people say, well, concrete's cold, but we can also put wood flooring on it, carpeting if you want. But there's lots of different opportunities that we have that are less expensive than framing.
Doesn't it make it hard for like plumbing and things like that, especially if there's a pipe that bursts, or is there a way around that issue?
Well, with the materials that we're using now for plumbing, it's not very common that we have burst pipes. Wastewater is conducted through ABS. Everything is sleeved through the concrete, so it's not bearing directly on it. ABS tends not to fall apart under concrete slabs. That's not common. Older pipes, when slab on grade built in the 50s, would have been cast iron, and those pipes rust, they break. There are maintenance issues, but today that's not the case. Uh, any plumbing that runs through the slab, we try to run the water supplies above the slab through the walls, which they're going to be going through anyway. Um, and so we only put the essential pieces below the slab when we have to, and it's typically just sanitary sewer drains.
Thank you. Do you require a deeper foundation because it's heavier for a
Every
slab?
every project is different. In terms of the foundations, but so I can't say that it's heavier or anything. I mean, there's more concrete certainly, but you don't have framing. So
And if you're comparing light gauge steel to wood, yes, steel weighs more than wood on a volume basis, but because this you actually need less of the steel to frame a wall, a steel frame building is actually lighter than a wood frame building in, a one to one comparison. Two people can tilt an entire steel framed wall into place, a light gauge steel framed wall into place. So it actually ends up being significantly lighter.
yeah, I wasn't sure whether you were talking about foundations or the weight of the building.
I
Uh,
I just wasn't sure if the slab, would be require more foundation because of the weight. We have a hillside in the front, so
right.
like 6 feet from the house, so it's foundation's a big factor.
Yeah, so the slab doesn't add to the load significantly of your foundations. It becomes integral to your foundations. So it all becomes a piece, and it's all engineered to work. So if you have caissons, it all works with slabs and grade beams, and it all becomes one pour versus pour the foundation, then build the floor. It simplifies things. I mean, but there are certain projects where that often makes sense to have a perimeter foundation and then floor framing, which we would do out of light gauge steel. We use a lot of times we use C-channel floor trusses. They don't squeak. They don't rot. There's no termites. There's a lot of advantages to those. So, but again, it's site specific. So if that's the particular nature of your site, we engineer the building to work for your project.
Thank you.
Good morning, guys. This is Vache.
Hey,
Just
gotcha.
in terms of permitting and inspections and light gauge steel, have you had any issues or additional roadblocks with inspectors on the light gauge steel as opposed to wood framing, which is more common in Southern California?
We
Yeah.
we have not. We get these projects approved without issue. There's ICBO approvals for the framing system. So what that means is that it's accepted by all building departments. It's even typically Los Angeles has an LARR, Los Angeles Research Report number, but they use ICBO. So that ICBO is actually what they go to in order to get approvals. So no, we don't have any issues with approvals. And we have
We have the same inspector that comes by for every project in Altadena, and I mean, I'm assuming that they see a steel frame structure once in a while, but there's like what, four, five, six inspections that take place on a property, and we want to avoid any kind of hindrances in terms of material usage. So you don't see any kind of hindrances by using steel, huh?
no, no, we
No.
have we have
Steel
Excellent.
steel frame has been in the building code, I think since the late 80s, early 90s. So it's been there. But again, a lot of builders are used to using it only in commercial projects, tenant improvements where they have to use non-combustible materials. They don't, and again, the traditional way to use it is to cut it in the field and it's loud and creates sparks. So a lot of contractors are used to using light gauge steel in that capacity, but they're not familiar with a machine that's printing it to size to get screwed together. So it's a newer application of an old technology.
Got it. My other question is in terms of design, like the picture we see in front of us, we have a modern design next to, I guess 1950s ranch style. Are there any restrictions in terms of rebuild? Like, is the code or is the permitting authority saying they prefer one style over another, or is it just a mishmash? Because I can't imagine what Altadena is going to look like after everybody's rebuilt. It's like there's a million types of designs we're going to see.
Right. And sometimes variety is good, but when it comes to the building department, they're not concerned with the style of the building. If there's an architectural review board that's a separate entity that would come before the building department reviews it. And in our experience, we haven't had any issues with additional reviews. I don't think that there would be a authority in the Palisades for that. Um, and if there is, we're willing to, work with whatever, jurisdiction approval we need. Every project is different. Every homeowner has different values and, a design sensibility. So we work within both the clients and the jurisdiction's requirements.
Excellent. Thank you, gentlemen.
Of course.
It's a beautiful house in that picture. Are those eaves feasible, you think, in the fire zones now, or what are your thoughts?
So this would be an example of us using something that looks like wood, but this is aluminum panel. So Ron was talking about some of the products that we use. Again, it's an aluminum, or they also make steel products that do this, where they screen print a wood pattern on them. So not only is it non-combustible, it's zero maintenance, whereas maintaining ipe would be an annual process of maintenance and resealing and things like that.
Wow, wow, that's unbelievable. And so that you think that would be a pretty good, call given being in a fire zone if the eaves are aluminum.
Yeah, yeah.
Okay.
yeah.
So non-combustible materials, and a lot of the window frames we're designing with aluminum frames, which normally the energy code wouldn't allow, but in a fire zone, they don't want to see vinyl windows that are, combustible, wood windows that are combustible. So the thought is that all of these are changing, and insurance companies also want to see non-combustible materials. So these are not only valuable for the homeowner, but that makes sense, as far as insurance goes.
Thank you. I noticed that you don't build with concrete siding, or what are your thoughts about that?
No, we will use whatever material makes sense. The two case studies that we presented today are light gauge steel and heavy steel. Ironically, Ron and I met doing concrete research at UCLA, so we have probably too much experience working with concrete, but we've designed with it in projects. We just didn't include it in the presentation today, but sometimes concrete makes sense. It all depends on cost. With concrete, the material is really cheap, but the labor is often where the cost can rise. So it depends on the project. We're working with a developer who's has his own kind of proprietary system for concrete construction and is proposing that for a lot of their new projects. So yeah, again, we're material agnostic when it comes to these decisions. We just want to deliver the best product and what makes the most sense.
And one of our biggest concerns is budget because we know that, if you've lost your home, you have limited budget to rebuild it. And so the systems we're proposing are the most efficient value for quality. And concrete, we love beautiful concrete buildings. We as Joseph said, we design with them, but they are more expensive.
That's really helpful. Thank you. Did,
And
uh,
if you'd like a high-end luxury home and you've got the budget to do it, we'd love to work with you too. You know, that we're targeting people not targeting, we're targeting to help people that have limited budgets here. But we design with all sorts of materials.
that's great. Have you seen research on homes in the burn area and materials affecting insurance policies? And what are your thoughts about that?
Yeah, I think our approach has been, let's design above and beyond the code requirements so that when an insurance company does, evaluate this, you can tell them this is a steel framed building. These steel frame buildings, when you take wood rot and termite damage out of the equation, these can last over 100 years. So we're designing something that's inherently more resilient and should have a much longer lifespan than traditional construction. Um, but yeah, that's just another asset to describing the project when it comes to insurance and having them evaluate it.
I-
Ron, any thoughts on that? You asked also about other, materials from our research. Ron covered a lot of them, based on some of the case studies that we saw, and there's been a lot in the kind of just in the world of architecture describing how to, reduce vents in the roof, vents in the foundation. Those are all entry points for potential embers. Um, so having closed eaves versus open eaves with vents, those are all things that we've integrated into these projects.
One of the things we also do is, you can look at new developments in a lot of places and new homes by developers and home builders, and you look at their roofs and they've got plumbing vents peppered all over the place. And we really design so that our plumbing vents are very limited and they're actually not even, for the most part, not even going through the roof. So we're really trying to eliminate entry points not only for fire, but also for water and allow you to have the maximum area for potential solar, photovoltaic solar on your roof. And plumbing vents get in the way of that. And we consolidate, we streamline, we we pre-engineer all of the surface services of your building as we design the building to try to make it the function the best possible way.
Wow, sounds great. Beautiful work, guys.
Thank you. Thank you for your questions too.
Are they requiring everyone to do solar just to be up to code now with these builds?
So the requirement has been reduced to solar ready. So in order to incentivize rebuilding and to spur things along, it just has to be solar ready. So, the solar panels don't have to physically be installed for them to meet the approvals, just the appropriate space in the electrical panel, and the roof has to be structurally sound enough to take the weight of the solar panels and things like that. So, normally in the building code, that new construction would need to have solar installed, but they've kind of reduce that requirement. So it's just solar ready for these fire rebuilds.
And one of the things that we like to use steel or aluminum roofing products for with the standing seam is that the 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 armatures for the solar panels will just clamp to the roof without penetrating it. They clamp to the ribs. So it's one of the advantages, and they can be moved around to be the most effective location for the building without putting a hole in the roof.
That's great. Thank you.
Thank you.
Have you guys, in Altadena in particular, have you guys heard about the issue of expansive soils and
Expe-
possibly,
so yeah, so what you need to know about expansive soils is virtually every project has expansive soils. And
hmm.
so it's just something that is engineered, with the structural engineer make sure that the footings are sufficient for quote unquote expansive soils.
So materials like clay, they'll expand when wet, as we're seeing now, and then when it dries out, it'll compress, and so that expansion and contraction under a slab is can cause what's called differential settlement. So if the slab isn't designed properly, it's not properly engineered, that foundation might settle. There could be cracking with that slight movement. So that's just, part of the structural engineering to either design the slab that's thick enough or, properly get a soils report and understand where the different soils types are on the project.
Yeah, and it's compaction of the soil. It's sometimes depending upon the severity, they'll require removal and recompaction, and and that's it's just one of the processes that has to be evaluated by the structural engineer. Um, so, but almost every project has expansive soils.
Yeah, it just seems my neighbor is building at the moment, and that is their major hurdle right now is they're having to re-engineer the foundation
Yeah.
because either they didn't get an accurate soil report at first or something changed. But to your knowledge, no requirements have changed, correct?
Yeah, no, the requirements haven't changed. It's just making sure you do your homework for your site.
Hmm.
That's what we do.
And that's homework that we would do.
Yeah,
So
Yep.
yeah. So any other questions? We're happy to set up meetings to review your specific project, your site, with anybody that wants to talk about their project. You can reach us from info@formfounddesign.com. There's two D's back to back there. Or you can just go to our website. You can get a link to uh, email us, which is
and
formfounddesign.com.
Thank you guys. Beautiful work. Thanks for your time.
Yeah, thank you very
thank you
much.
for listening in. Thank you for
Thank
the
you.
questions. All
Okay.
right.
With that, we're gonna close this session.